way you can use email, and you can basically
Okay, we're recording.
all day if you want. But there's nothing like person-to-person contact.
Whenever you guys want to start.
All right.
The kids are like they're like zombies with texting.
All right. If I could have your attention, please. Welcome to another of our brown bag seminars focusing on living with drought. Today we have two excellent speakers who are going to be speaking on the effects of drought on natural landscapes, especially forested landscapes, and what you can do to help protect your home and your forest here in Sonoma County. Our first guest will be Carleone Safford, who works as the coordinator for Fire Safe Sonoma. And take it away.
All right. Hi, everybody. Most of you have seen this already, so those of you who haven't,
Always a good reminder.
yeah, well, just interrupt me. I'm going to be talking really fast because I was supposed to make this 20 minutes, and I'm like a minute over. So I'm going to have to say, okay, so you follow me? You do? Okay, okay. Yeah, usually I call the presentation is called the Wildland Wiseacre, how your home can help save the forest. They wanted me to do something special for the drought, so I had to rename it. So I renamed it the Wildland Wiseacre, or how your help can help save the forest squared. Because the truth is that there's nothing different in my message than I would have in a message any other time, except for that this time, instead of just talking about doing it and going to a meeting about it, you really have to do it, because the risk is definitely a little bit more this year. So what I'll be talking about a little bit, wildland fire and wildland fire suppression in the United States. How homes in the wildland-urban interface and intermix, which I will often shorten to WUI, influence our approach to wildland fire and the factors that drive home loss. And how your own wildland wiseacre and your wildfire-compatible home can actually help us to save the ecosystem. And the first thing that I need to talk about is how important wildland fire is. It's inevitable, and it's a principal, crucial ecological process in many parts of the world, and certainly in California. So the first thing I talk about is not put them all out. It's actually, we really need this stuff. And if you look nationally, this is statistics for the lower 48. Currently what we're burning is roughly 7.5 million acres a year. That's about 5 million in wildfires and about 2.5 million in prescribed burning, which is primarily in the southwest of the United States. Anybody want to hazard a guess of the historical norm? Propylene, roughly 35 million acres. So we are burning a lot less than we would have been burning, 100 years ago. So, and this has had a huge impact. Now, how did that happen? How did we get 35 million? Well, 10 to 15% of wildfires are caused by lightning. The rest are caused by three things, and three things only, and those three things are men, women, and children. That's us. We're really good at that. We're humans. We do these things, right? And in the past, humans certainly did a lot of fire on the landscape here in California, in that natives used fire to help make the harvest easier, to renew certain plants so that they produce better, all kinds of stuff. These slides look kind of familiar to you?
No, never seen it.
I stole these from Arthur. So that was how we got to 35 million acres. Was that was one of the ways. And plus, we didn't put them out. So how did we get to 7.5 million? Well, early on, as of about the 1890s or so, the federal government started going, "Oh, we must put out these fires." First off, it's those pesky Indians that are starting them, and we don't like that kind of stuff. But also, they were perceiving this is valuable stuff. We can't just be burning this out. We have to put these fires out. And so they started doing that early on, bringing the Army into the process. And that process has continued up to today with, lots and lots of people who are out there squirting water on fires and have lots of equipment, and big and small and all kinds of stuff. And I'm one of them, so I will attest to this. Exactly how this works statistically. This is kind of interesting. So what we have over here in this column, these are fires that happened between 1933 and 1953, so that 20-year cycle. And what we had typically in those years was we had an average of about 2,816 fires per year, which consumed approximately 300,000 acres, right? Now, over here in this column, what I've done is I've moved the years up. So we were starting at 88 and we're going to 2008. So we've just fast forwarded. And while we had an average number of fire starts in that time, the average was roughly 6,000 fires per year, which is consistent with a larger population, right? Men, women, and children. But what's interesting is that here we were burning 300,000 acres with 2,000. Over here we're burning only 176,000 acres. A lot of little fires, right? And so this is what we've done. This is how we've managed to, put all these fires out. Now, one of the reasons that this has been so important is this thing right here, which I was talking about earlier, which we call the Wildland Urban Interface, or the WUI. This is just a screenshot from Google Map I did yesterday of Fountain Grove Parkway, right here in Santa Rosa. Now, this area is like, holy cow! Hanley Fire, 1964, started in Calistoga, burned all the way to the Sinead Hospital. 54,000 acres, I think, took out, only 108 structures, but that's because there weren't that many structures in that giant footprint. Today there are. Every one of these houses is in the footprint of that fire. And so, if a fire starts over here, you better believe we're going to be trying to put that out, because this is a lot of houses up here that hypothetically could go down. So it's very important that we do put them out, and so that's what we've been doing. Yeah?
Just a quick question. Do you have any idea if the fire danger was factored into the planning of this?
Yes,
it was.
It was to some degree. And I've worked a lot with actually one of these communities over here. I've worked a fair amount with them. They are doing a lot. They've hired a really good forester out of Marin who's done a lot of work in these areas around here, getting rid of stuff and stuff. So they're really paying attention. I will contend that they still need, what they can't do is what I'll get to later, remind me. Okay, pop quiz, right. What percent of wildfires do you think are controlled at less than 25 acres, right? So we get out there, we squirt water on them, and we get them out before they're 25 acres or bigger.
90%.
Close. We're up to 98.
Wow.
That's where we've been. We've been at 98. Yeah, you're a good bear. You're a good bear. But, there's a big but here. Fire has huge roles in the ecology, as we talked about. It has roles in regeneration of forest ecotypes. It has roles to keep overcrowding from happening. And this is a great example. This is my neighbor Tanya, whose grandfather, this is about 1900, painted this scene. And then Tanya went out and took a picture of it for me. This barn here is this barn here.
Wow.
Look at this hillside. You can see it's a South Savannah. You can see it. Now look. It's all tan oak and our friend, the invasive native Doug fir, right? Which are both also pretty fire-prone species. So, things are really changing. We have a lot of trees out there. A lot more trees, I think, than we used to. And I think a lot of Arthur's work, definitely. That's why every time I hear people going, we're going to go plant trees, I'm like, no. You go cut them down and you'll make me happy. Whoops. Because in uncrowded forest, if you get a fire comes through, it burns through, it cleans up the stuff on the surface, it doesn't kill a lot of big trees, takes out a lot of pathogens, does a really good thing. When you have an overcrowded forest and you have ladder fuels under there, you have much more significant fire behavior, burning much higher, much hotter, doing a lot more damage to the soil and all the organisms. It's a bad thing. It also, when you get all that crowding, you get critters like beetles and borers and pathogens like sudden oak death. And so you start, the forest conditions start to degrade as well. So am I good or what? Well, yeah, and then, till anyway, right? Now I'm going to relook at these statistics. Now that big chart I just showed you from 33 to 08. So we had approximately double fire starts, a little more than that actually. Now let's up this and change the years from 60 to 11. This is really interesting. So now if we look at it, if we're looking nationally and in California, so we had double the fire starts, which was consistent from 60 until 70. We still had more, we were still going up. But as of 1970, the fire starts start to drop. Now why that is, I'm not sure if that was just more, because these are going to be large fires, right? These are, whether it was just they were picking up more of the fires or what, or there were more of us who had grown up with Smokey the bear, and so we're actually not starting as many fires as possible. But here's the interesting one, right? So, in the other data, we had approximately 60% fewer acres burned, even though we had more fires. Remember that? Now look what's happening to the acres. We're still having, less. We're still having less until right here, 1980. All of a sudden, woo, we're going uphill. The acreage is going up a lot. We are losing the battle all of a sudden as of about 1980. And any of you who've been around that long, and I think most of us have, can remember a lot of those fires, Southern California fires that started taking on, and we're starting to lose more faster. We are beginning to slip, right? We've been able to get by with all this fire suppression for all these years, but now we can't. By suppressing the 98%, we've created overcrowded forests. We've encouraged pathogen that further degrade forest conditions. We've encouraged people to think that it's totally fine to build our homes in completely inappropriate places. And then we expect that the fire department's gonna come along and save my butt, and if the fire doesn't save my butt, then the insurance company's gonna pay me off, right? So we have this whole paradigm of like we're building houses in stupid places and thinking somebody else is gonna save us, right? It's a problem. Now let's bring on climate change. Now let's throw that into the picture, right? So we've got drought happening, no doubt about it, right? We've got, this scares me more as a firefighter, this scares me more. We had climate change, we had in 2008, that was like lightning like crazy. We had more than 2,000 fires burning across the state. Fire agencies were completely overwhelmed, right? And the good part of that was that these fires were burning and no one was available to put them out. So we were finally like letting fires burn, which I think is what we really need to do. But when you combine those two things, we're gonna have some, fuels are gonna be drier. And that's gonna make a longer fire season. That strains budget, equipment, and personnel. There's gonna be lots of fires statewide, and that means that stuff like helicopters and airplanes, which I hate to tell you this, I hate to admit this, but when I go out on a wildland fire and I'm squirting fire with a hose, if it's a small wildland fire, we can get it out with our trucks. If it's a big fire on a bad day, we don't have a prayer. We have to have that air support. That's the only thing that's going to get them out, right? And if there's huge fires in Southern California, guess what? They're not here. So, that's going to be a problem as we move on. Lack of water for irrigation, people are changing stuff. It's hard for us to scoop water up for our trucks. This is going to be the worst fire season ever. Well, you know what? Has anybody ever heard that before? Right? Every year, it's going to be the worst fire season ever. And you know what I think? I think, yeah, we do have a drought problem. There's no question about it. But every year in California, we have a wildfire problem. This is nothing new. It's just, it might be a little worse, but it's really no different. And I personally think, this is my rant. I decided, since I figured most of you guys had seen this before, I would rant today.
You like rant.
Well, I think the bigger problem is how we approach wildland fire in the wildland-urban interface and how we educate people about what they need to do. So I think that our approach and our education is just totally screwed up, and it's very annoying to me. So, first thing that I find really annoying is we continue in all of our efforts, we're always focusing out there, far away. We don't focus on the 100-foot defensible space, and we're focusing on this, this much bigger thing, and we think it's going to do a lot of good, and it's just not. And we keep on allowing, planning departments keep on allowing for building in weird areas, and I was just having a little scrap conversation with the Sonoma County Fire Marshal, who happens to be a good friend of mine, the other day, about this very issue, right? And she's like saying, well, it's property rights, Carol Leon. We can't tell people where they can and can't build their house. And I'm like, we have to. And we're still providing like tons of funding for big trucks and airplanes and equipment, and very little funding for teaching people what to do to keep their house from burning down. And these are the things that are very, very frustrating to me in my shoes. Okay, my rant, it's not over, but that's most of it. So what we need to talk about is how the heck does this happen, right? Because this is the tail that wags the dog of fire suppression in the United States. It's when you lose a bunch of houses like this is when everybody gets all bent out of shape and the money starts flowing and everybody starts doing stuff. It's all about home loss, right? Which makes sense. So how does this happen? Well, this is a logical process. You get a day where you have severe fire conditions. It's hot, it's dry, it's windy, and there's slopes and there's stuff. And then you get a wildland fire start, right? And it goes fast. And then you get poof, 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 you get houses starting to go off. Really soon, the fire protection resources are greatly overwhelmed, and their effectiveness goes down. And lo and behold, what do you get? Tons of destroyed homes, so that you get that scenario like in that picture before. Well, what happens if you take this out of the system? What if you have homes that don't ignite, right? That solves basically the whole problem. And we can stop chasing our tail on this thing and actually start looking at the things that we can do that can improve conditions in our forests and for homeowners, right? So that, I mean, it seems ridiculous, but it's true. If homes don't ignite, homes don't burn. And if homes don't burn, we can begin to allow fire to return into its proper place in our ecosystem. Or at least that's my big fantasy, right? Okay, so that's why this home loss thing is so important to me. We have to grab this, hold of this, right? And we do have some technology that can allow us to do that. Whether or not a home survives a wildfire fire depends primarily on two factors. Number one is the structure itself and the elements on the structure that make it vulnerable to ignition, okay? Two is the 100 feet or so, plus or minus, depending, surrounding it, right? That defensible space zone, there's, home ignition zone, there's lots of different words for it. And this guy is Jack Cohen. Find his work, read him, he's, my God. So, we need to focus our attention on increasing awareness about structural hardening, making this ignition proof, and how we can achieve it. This is Hayman, Colorado. This is one of those big fires. This was a Lollapalooza fire, and this house survived. I don't know if there was trucks there or not. Maybe, maybe not. It looks like it was pretty, well put together. This is something that's possible to do, right? If we do that, we can have significant wildfires. We can have significant wildfires without having significant home or life loss. It's possible, but we have to go about it the right way. And how do we currently approach this issue? Well, we look both on a national, state, local, and individual level. We want to look outside for the problem, right? We prefer to think of it as a vegetation problem, and we hate thinking that our beautiful homes are the issue, right?
Shingle roof, I can't have my redwood shingle roof.
This guy, now how many people do you think told this moron that? I'm sorry, I get really mad at this guy. This is a photograph that it showed up in the LA Times after 2003 fire siege down there. And the headline was, "Firefighters lose home." I was like, excuse me? How many people told him to get rid of his wooden roof? And he didn't do it in LA. Firefighters didn't lose that house. He lost his house. And he just didn't want to listen. And we're much more comfortable focusing on vegetation, especially if it's not our own vegetation. Like how many times people call you up, right? And they're like, "No, it's open space district. We're all going to die because of you people and your fire fields." And you go to their house and it's a mess, right? They don't want to focus on that. They want to pick on somebody else who's far, far away. Human nature, but it's a bummer and I'm tired of it. Can you tell? Now, this is not to say that I don't like vegetation management projects. I do. In fact, this is one that I funded and ran, right? Vegetation management's great, especially when it improves forest health. But to change the suppression paradigm, we really need to start looking closer to home. We need to start working on home loss as our primary focus. 2% fires are going to happen, right? The ones that get away. And we're going to get more and more of them because of the change. We can't choose not to have wildland fires. But we can choose to keep our houses from burning down. Most of us have chosen to move into rural areas, right? And that, to my mind, that makes us personally responsible for making sure that our homes are wildfire compatible. It is our responsibility to do that. We owe it to ourselves, we owe it to the land, right? And it's also the only way we're ever going to manage to begin to work some change in the whole suppression paradigm that we have. And there are two ways that we can do this. So what do you got to do? Increase the fire's ability to withstand amber assaults, and you decrease the fire, the fire load around the house. Two things. And it's like, and I cannot overstate the importance of looking at the house. And I use this photograph to illustrate that, because these are what?
Eucalyptus.
Oh my God! If there's one within 50 miles, it's going to kill you. That's the way people are. They freak out about eucalyptus, right? And look at all these houses. So the fire obviously carried through these eucalyptus to burn this house down, right? That's how the trees
carried
are
the fire
kind of
through the
okay.
eucalyptus and didn't burn them.
I think the tree should have sued the houses, putting them in great danger. It's in San Diego. I'm pretty sure that there were probably wooden roofs in this neighborhood. I don't know that for sure, but I think that there probably were. Because I grew up in a very similar neighborhood in San Diego, in a house with a wooden roof, right? So, probably one of these houses got burning and radiant heat got to the next one around down the street, right? Homes are fuel too, and we really need to remember that. So what exactly makes homes burn? It's science, right? We have two things. We can have direct flame contact, which is you let the stuff grow too close to the house and the fire just uses it to get on the house. And then you have radiant heat, right? And that's when something's close enough that it gets hot enough that it actually ignites the house even though the flames don't touch, right? That is under your control if it's vegetation. If you live in a tight neighborhood, this is a problem. Because if you have a house right next to you and the house gets burning, it's pretty hard to deal with that. But these are largely defensible space issues. The big issue, and the one that we really have to deal with, is the ember thing. Because that's what's really most likely to take your house out, far more likely than the other two. Embers can be small, grain of rice, big, and they're blowing everywhere during the wildland fire, right? And in order to protect our homes from the embers, we need to actually, that's where we need to treat the structure. That's what I'm talking about. And let me show you how this works in the real world. Nope, not like that at all. So you have your basic wildland fire. Oh, it's not loaded. I forgot to do that. Oh, I'm such a bad person. Anyway, the moral of, I'll do an interpretive dance.
Embers.
Embers! And what we have under this house, there was a broom. This is the long story. So we have people like wandering around there squirting fire everywhere, and all of a sudden they're like going, whoa, look at this. And he comes out and he's got a flaming push broom, right? Now the fire probably wouldn't have taken the house out. The broom would have taken the house out. It's the little things. It's the little things that count. Because these embers are blowing in anywhere. They're blowing on the bloom, they're blowing on the gutters and the cracks in the siding, furniture on decks starts a lot of fires.
Roof vents.
Vents, attic and foundation vents. Under the house, open doors, windows, they're blowing all over. So this is not a vegetation issue, right? This is a structure issue. Steve Quarles, another one of my heroes, who came up with this list. I've got to talk really fast now. Of the things that you should address to address these problems. I'm pretty much only going to talk about the first three, and then I'll really cruise through the next one. Don't do that. If you have an old comp shingle roof, you need to change it. It's only good. It's only Class A as long as it's sell-by date is for. So just make sure your roof is together and good. If you have tile, make sure you stop them so the birds don't get up there, build nests, which then take embers and burn down. Same thing with metal roof. That's one of the things I find is people say, oh no, I have a tile roof, I'm totally cool. So, no. Eaves and vents, check your vents. Code for vents used to be 1/4-inch mesh, which is plenty of room for a very large ember to blow in. Embers blow in through the vents, get into the attic, and your house burns from the inside out. Hours after the fire front has passed. Hours, right? Big issue. There are lots of products on the market now that you can use to retrofit. So do some research, figure it out, and take care of it. Steve Quarles puts vegetation at number 3 because these other two issues are so much more important. So that's where he puts defensible space. And I'll talk about that later. But I have my own number 3, which I think is just as important, which is our stuff, right? Because we all have tons of stuff lying around our house. We have wood piles. I have a ton of those. We have, mats that ignite and wooden planters with dead plants in them. Pet doors. I put this up here because if there's a fire coming and if you're evacuated, you need to close that pet door because it will blow open and the embers will blow straight in your house. So people don't realize that. Never thought of that. I know. That's why I leave it there.
I'm walking away with that.
There you go. I might have just saved your house. Woo! But why? Brooms, right? Duff right up next to the structure. 30 feet away with that stuff. Firewood. Even in a Louis Vuitton trash bag. Trash. Look around your house for the stuff that can ignite and move it away from the house. It's going to be that little fire that's going to start after the firefighters have left The fire's burned through, everything's mellow, those guys are fighting a fire in some other neighborhood. And one of these little embers lands somewhere, and that fire just grows and grows and grows and takes your house out. This is your control. Windows should be double pane because they withstand heat better. Decks, replace them with non-combustible if you can, and if you can't, keep them clean. Certainly don't put stuff under them. Siding, whenever I say structural, people, the first thing they think of is siding. Oh God, I'm gonna have to, you don't really have to replace your siding unless it looks like this. That's pretty bad. That was my house.
That's your house?
It was my house. And if your siding looks like that, you need to replace it. But otherwise, it's the last of 6. It's 6 of 6. So move on. Learn about it. Do your defensible space. The defensible space is about the vegetation and what you're doing, right? This is not defensible space, right? Defensible space can have trees and plants and animals and happy things, right? Vegetation's allowed. Important message. You know, you want to just get rid of the ladder fuel so that if you have a fire start, it's not going to do this, right? Huge difference in how this is going to burn if I have these or I don't have those, right? So get rid of the ladder fuels, okay? That's really important. And those are the fuels that fire can use to burn across up to the house, or it can use to get up into the treetops, which is where we can't get it out no matter what we do. You can remove too many trees with terrible unintended consequences.
I love that picture.
And so consult an expert. Always, always, this one drives me crazy. People want to start like way down there on the back 40, and I'm going to work backwards. Start at the house and work out. Start at the house walls and work out. Crying out loud. Sorry. Easy way to remember it. Lift fuels up so that you don't have fuels that can lead straight up into the trees. Separate trees and shrubs so that you can't just transmit one to the other. That's right. You need to lift and separate. So, it's inevitable, wildland fire. It's going to get worse because we've been making it worse by putting them out all these years. It's all about what we do to our homes and in the 100 feet. And it's our responsibility to do that as people who think that we want to do the best thing for the land. And this guy, you know, this guy's done great. He's been great. But, you know, it's like this image, I always like kind of want to leave with this. This is like a shovel is a tool. That's a firefighter tool. I have that on my fire truck, right? This is not an only you. This is an only you, right? So, you know, that's where we're at. It helps us coexist. And there's my stuff. And
Good.
I used up my time.
Yes, you did.
Excellent. Thanks.
Thank you very much.
Now you're really in trouble.
That's all right. Steve can knock it out in 15 minutes.
No, that's not gonna happen. So I will warn you guys and apologize ahead of time. Is it already up? Do I just hit escape?
Yes, you can close that out and you're right on the bottom right there. Bottom right. There you go. And maximize
You have
it.
like a checklist you can go around your house and say,
Oh,
There's
right,
time.
don't just run it?
just go online.
Sure, if you like, that's fine.
I have some too.
Probably
I have
getting-
one I've been working on
we're
for
good.
years.
Okay, so I'm gonna run over as well. I just could not get my talk down, and if you have to walk out, I will not be offended. Oh, and I should stand where everybody. Okay, so I'm gonna just be talking a little bit about tree physiology and the drought and how it affects trees and what we can expect to see in our forests as a result of that. But before I do, sorry, I want to mention that it's been 100 years of cooperative extension existing, and I know this is going to sound a little bit like marketing, but it's actually just sort of a recognition about what the Sonoma County Forest Conservation Working Group is, because cooperative extension is basically all about getting science out to people. It's people working in the service of the counties in which they live. We have been around for 100 years. We've been working with CAL FIRE and other organizations that have also been around that long, and then a lot of organizations that haven't been that long. But so I just want to pat everybody who works with me in the room on the back and say we've been doing good work and we're going to continue to do good work because we turn 100 on May 8th. Cool.
Yay.
Okay, enough about the
So
patting
do we have
everybody on the back.
cake? That's what I'm asking.
Oh, yeah.
Where's the cake?
So we're going to talk a little bit about tree physiology, and I know you guys know this, but physiology is all of the biological processes that allow an organism to function. But really when I'm talking about physiology, I'm mostly going to be talking about photosynthesis, because that is the underlying process in plants that drives everything else. So, and this actually begins to matter. I know you're going to be thinking, why is he talking to us about this? But if you don't know, chlorophylls tend to have 2 absorption spikes. And there are 1,000, people talk about chlorophyll like it's one thing. There are 1,000 different chlorophylls in the world. And they're loosely grouped in chlorophyll A, chlorophyll B, but each plant makes its own, and they have these crazy combinations of chlorophylls that they put into every single leaf to tailor that leaf to the light environment in which it grows. So do you guys know Ficus benjamina? It's a little ficus tree that grows in people's plants.
Yep.
You ever notice that if you move it, it drops all of its leaves and grows a whole new set?
Yep.
If you're lucky.
If you're lucky, right. Ficus custom builds each leaf to its exact location. That's why when you move the ficus, it drops all the leaves, it reabsorbs all this stuff, rebuilds all those chlorophylls, retailors the sweet to its whole new location. Most plants tend to be a little more flexible with this. They can rejigger their leaves in place to deal with different change conditions within limits. Otherwise, they end up having to drop them and do the same, the ficus trick. But what this is about is, it's about blue light is the highest energy light. Blue light will break chlorophyll. So chlorophyll works in this very narrow range. If it doesn't get enough light, it basically doesn't work at all. If it gets too much light, it breaks. The molecule itself literally comes apart. And since plants make their food, which is sugar, from sunlight, that's a really bad thing if you are cut off from your food. Well, what they have is they have a bunch of pigments, a number of different chlorophylls to try and take as much of this blue spectrum and that red spectrum as they can. This green spectrum is useless to them. They can't use it to manufacture anything. And some of this blue light is so high energy, and it often comes in at such intense levels that they have to create these special pigments to shield the chlorophyll to keep it from being broken by high levels of blue light. These absorb blue light and they reflect it back as reds and yellows. So after you take all the chlorophyll out of a leaf, you're only left with these accessory pigments. That's why leaves are red and yellow when they begin turning. The plant pulls all the chlorophyll out, and these accessory pigments are the only things that are left in that leaf. So that's why it turns. Okay. So we can look at plants and look at the color of the foliage, and it will tell us a story. Trees, so to make a long story, summarize, trees metabolize these sugars to live, grow, and reproduce. They have to live within a budget. You can do some deficit spending if you're a mature tree, but you can only do it for a little while. Okay, so this last winter we had some pretty hard freezes. This mostly affected broadleaf evergreens, and that includes to a large extent things that are subtropical, because most of the temperate broadleaf evergreens we have can handle it. But ukes are basically subtropicals, citrus are subtropicals, so we started seeing burn on all of these things. And you know, freeze effects affect everything. You know, it's just a question of how cold does it have to get. And once you hit about minus 40 degrees, that's the same temperature in Fahrenheit and centigrade, that's the limit, and that's why larches are deciduous. But the leaves are the most vulnerable, so that's typically where you see it, the burn effect. And water protects these trees in a number of different ways. And drought predisposes them to this damage. They need water to protect them from frost. So that's one of the reasons we see all the eucalyptus out near the coast right now all being fried, is because we had drought. And with drought, they didn't have the water they needed to defend themselves adequately. And then we had some really cold temperatures. So this is being done, these are parenchymal cells of cucumber, and that means that that's what this graph is built on. But this graph looks the same. You know, if it's a spruce tree instead of a cucumber, this temperature will be radically different. You're shifting the scales in terms of time and temperature, but the graph still looks the same. So what you first get is, as the temperature drops, you get this supercooling effect. And this is basically the energy from the leaf is going to the droplets of water on the surface of the leaf, because before it gets to this effect, you generally have dew condensing on the leaves. And so the leaf is the energy is going from the leaf, and it's going to the water on the surface of the leaf. So once it hits about -4 or -5 degrees, you see this big spike on the internal temperature of the leaf. And that is what happens when the leaf energy stops moving to the water and starts moving from the water on the leaf back to the leaf. Because this jump is when the water on the outside of the leaf freezes and the energy moves back in. So the leaf actually gets warmer when the water on the outside of the leaf freezes. That's a good thing. This helps plants withstand some of the amount of heat loss. But then that protects for some time, depending upon the plant and a number of other things. And then the supercooling occurs again. And we start getting, water freezes here at about 0. Actually, it tends to freeze more about here at about -1. And it will freeze here if you leave it there for long enough, but typically the temperature's dropping faster than that, so you end up with things. This is now the water on the inside of the leaf beginning to cool. And first it freezes between the cells. And that's what this little bump is, right here. There's a lot less water on the insides of the cells than there is on the outsides of the cells, so it bumps, and then it keeps going down here. And that's about where the tree begins to decompensate. It can no longer compensate, and you start seeing these bumps, and these are all of the water inside the cells freezing and splitting and bursting the cells open. So why does this all matter to us? Well, that's how you get all those plants on the the ukes here that are freezing, and the reason they're showing such bad damage is they didn't have water. So let's talk a little bit about water. So there's some stuff we obviously know about water. When you have chronic water shortages, you end up with dead branch tips like this, as the tree once had more water and it used to be able to supply the water, but in the recent years, and we can tell it's at least 3 or 4 years, it hasn't been able to save these things, and it's been slowly dying back. But remember how I talked to you about all those accessory pigments, all those yellows and reds, and the lack of green, the tree pulling the water and the